new chapter, chapter 3 on exponentials and logarithms. And we're going to start off by just kind of reviewing some basics of exponentials. F of x, if you have a function, f of x is equal to 5 to the power of x. And I'm asking you to evaluate the function at negative 3.2 or to evaluate the function at pi or at the square root of 5. All you need to do is replace the x value with these values. So in the very first case, you're just going to put 5 to the power of negative 3.2. So you put 5, you raise it to a power of negative 3.2, and you get some value. I need some help with that. I know it's going to be a very small value. What is it? 0.0057. All right. F of pi. Well, you just put 5 and you raise it to a power of pi. I would get in the habit, you guys, now of whenever we're using pi, to make sure that you're using the actual pi button. Don't use 3.14. Use the pi button. And the pi button is the same button as your caret key, your power button. So you do second caret key to actually raise it to the power of the true value of pi. So 5 to the power of pi is 156.992. All right. So really remember. Sometimes I feel like students forget that pi is a number. When you see pi, they think of it more as a variable than they think of it as an actual number. But remember, pi is it's an irrational number. It's 3.145, et cetera, et cetera, et cetera. So it's an actual number here.
Wait,
F, yes.
For
Yeah.
A, shouldn't that be 0.0058 because it's
I don't know. Someone told me it was 0.0057. Is it 0.0058?
just
If
because
you
the number after you had to round.
you had to run, so it should be 58.
Yeah.
Okay. So letter A should not be 0.0057. Apparently, should be 0.0058. All right. F of the square root of 5. Well, that just means that you take 5 and you put it to the square root of 5 power. 5 to the power of the square root of 5. The square root of 5, remember, is an actual number. The square root of 5 is 2 point something. So you're really taking 5 and putting it to the power of 2 point something. So what is 5 to the square root of 5 power? 136 point, what did you say?
36.
Just 36. Oh, yeah. Oh my gosh, yes, of course. 36.555. All right. What if you have 6 to the power of negative x? By the way, these are called, both of these f of x's are called exponential because you are taking some number and you are raising it to a power of x. So whenever the power is a variable, like in these cases, that's an exponential situation. All right, so in this case, we're raising the x value of this is going to be a 4, f of 4. So really what you're doing is taking 6 and putting it to the negative 4 power because it says raise 6 to the opposite of x power. So if x is 4, you're putting 6 to the power of negative 4. Help me out. What is that? It's going to be very small.
7.7.
What is it?
0.72 over 5.
Point.
7.72 because I rounded the 7.1.
That's the negative 4.
Oh, an e. Okay, I was like, okay, that can't possibly be right. Okay. So it says on your calculator 7.716, and then it says e negative 4. It says more numbers, but that's okay. All right, it says more numbers before it says e negative 4, but that e negative 4 Hopefully you have some recollection of that. That means times 10 to the negative 4 power. When you have times 10 to the negative 4 power, that means that you need to move the decimal point 4 places to the left. So you move your decimal point all the way over here, which makes 6 to the negative 4 power actually equal to 0.00077116, etc. So make sure you're looking for that E, and don't be a robot. Don't write down E negative 4. Write down what it's supposed to be after you've moved the decimal over. If you want to, I'm also okay. If you would like to write 7.716, that's okay. But then instead of writing E, you guys need to write times 10 to the negative 4 power. So that E means times 10 to the whatever power after. So in this case, it's a negative 4. So it'd be times 10 to the negative 4 power. All right, f of pi. So it'd be 6 to the negative pi. What is 6 to the negative pi power? Is there an E in it?
Nope.
Okay, so it's just 0.00 359. All right, and then this one. Okay, be careful with this one because this one gives you a negative 1.2 power. So what is the opposite of a negative 1.2 power? Positive. So it's going to be 6 to the power of 1.2. 6 to the power of 1.2. What is it again? 8.58. 58. Is that right? Okay. All right, good. Okay, those aren't so bad, just a matter of plugging those. The only one I think that maybe would throw you here is the f of, this one right here, f of negative 1.2, because you got to remember that the x has to be the opposite, so you're actually finding a positive value in that case. All right. These graphs that show up next in your notes are all graphs that you have already graphed on that paper that we just finished before. So I'm not going to worry about those. You don't need to worry about graphing those. Let's move on to this part. If f of x is equal to a to the power of x, where the a value is greater than 0, but the a value is also not equal to 1, then what does our domain equal? What is our range? What is our y-intercept? Is the graph increasing or decreasing? What is our ha, which is otherwise known as a horizontal asymptote? And then is the graph continuous? So if this is what your graph looks like, what is the domain? In other words, what values can I replace this x up here with? Can I put negative numbers in for x? Can I find, let's say the a value was 2. Can I put 2 to a negative power? Yeah, we just did some of those in the examples right above. Can you put 2 to a positive power? Can you put 2 to a decimal power? Yeah, you can put anything. You can put anything in for x. You can put positives in, you can put negatives in. In other words, look at your graph. This graph will go infinitely far to the left. It will also, it's heading up, but notice at the same time that I'm heading up, it's headed toward the right. So it's headed toward positive infinity if we move to the right, and it's headed toward negative infinity if we move to the left. So the domain in this case goes from negative infinity all the way to positive infinity. Negative infinity, positive infinity. What about the range though? What is it always bigger than? This graph is always bigger than what y value? Yeah, this right here is the x-axis. What's the y value along the x-axis? The y value is 0. So this graph is always going to be above the x-axis. So we say that our range goes from 0 all the way up to positive infinity. Notice my parenthesis with the 0 because it might not look like it, but this graph never actually touches the x-axis. It's always going to be above the x-axis, which, by the way, if it never touches the x-axis, what do we call the x-axis? An asymptote. It never touches the x-axis, so we call it an asymptote. So I'm going to jump over here to the HA, the HA, the horizontal asymptote. Well, the horizontal asymptote we just said is the x-axis. What is the equation of the x-axis? Very good. It's a horizontal line. Right here, the y value is 0. So the horizontal asymptote is y equals 0. In other words, it is the x-axis. Is the x-axis. Is the graph continuous? Yeah, does the graph go on and on and on and on and on? It doesn't stop. There's no holes in it. There's no breaks in it. Is it continuous? Yes, it is continuous. What about the y-intercept? What is the y-intercept of this graph? It crosses the y-axis right here. What's the y-intercept? 0, 1.
Is it increasing?
Is the graph increasing?
Yes.
Yes. Is it always increasing? Yeah. So what interval is it decreasing over? When does it start to increase?
1.
Okay, so you're saying it starts increasing right here at an x value of 1. So right here it starts to increase?
No.
Yes, it starts increasing wherever it starts, which is at negative infinity. So this graph is always, always, always increasing. So the interval at which it's increasing is from negative infinity all the way to positive infinity. Easy enough, right? Yeah. Okay. Let's move on to the next part. Where's my? If f of x is equal to a to the negative x power, remember, as we just graphed on that paper before this, when we drew those graphs, we realized that when x is replaced with a negative x, all it ends up being is a reflection across the y-axis. It's a reflection across the y-axis. Okay, so what is the domain of this graph? What is the domain? Okay, positive infinity to negative infinity, but usually we start from the negative side and go to the positive side. So the domain is from negative infinity all the way to positive infinity. So in other words, the graph starts way over here. It's heading down, but if you were to move to the left on this graph, it's going up, but it's also headed toward the left also. So the domain is anything from negative infinity all the way up to positive infinity. What about the range? What is the lowest that that graph ever gets? What's the lowest it ever gets? See how the graph is heading down. Now, does it ever get to 0?
No.
Maybe that was a bad question because it doesn't actually have a low point. It will never actually touch the x-axis. It just gets closer and closer and closer to it. So the range is anything from 0, not including 0 though, that's why there's a parenthesis with it, and it goes infinitely far up. So it goes from 0 to positive infinity. Perfect time to talk about the horizontal asymptote. Is there a horizontal asymptote? Yes, there is. What is the horizontal asymptote? Y equals 0. It's the x-axis again. So the horizontal asymptote is y equals 0. Again, hopefully you guys are noticing some similarities between the two situations. So the horizontal asymptote is y equals 0, which is also the x-axis. Is the graph continuous? Does it go on and on and on and on and on? Yes. It doesn't have any asymptotes or anything like that. So yes, the graph is definitely continuous. Y-intercept. Where does the graph cross the y-axis? Very good. It crosses right here again. So the y-intercept is 0, 1. Decreasing. Is the graph decreasing? when you look at it from the left side to the right side, always read a graph from left to right. Is the graph decreasing? Yes. So as we head down, it is definitely decreasing. So the decreasing interval is what? Very good. It's the same as the domain. So it's decreasing from negative infinity all the way to positive infinity. All right. One more section that we need to talk about. This shouldn't take very long, and then we will, and you guys have your first assignment from section 3.1. Yay! And I don't think it's very bad. The assignment's not going to be horrible. So, all right. Formulas for finding compound interest. All right. So first of all, you need to get these down. Formulas for compound interest. There are two of them. And the two formulas that you need to be familiar and comfortable with is A equals P times 1 plus R over N to the power of NT. And that is the formula that you use if N compounds so many times per year over certain intervals, like once a month, or biannually, or annually, or daily, or quarterly, something like that. This would be the formula that you would use. And then the second formula, A equals P times E. Yes, that is an E. This right here is an E. We're going to talk about that in just a second. E to the power of RT. P times E to the power of RT. I like to use that formula, or I call that formula the PERT formula, P-E-R-T, like the shampoo. Isn't there a shampoo called PERT? PERT
Yeah,
Plus or
so.
something? There used to be.
Yeah.
Hi,
Is Jared here?
he is here.
Can I use this chair?
Yes. I want him back though.
It'd probably be literally 6 seconds.
Yes, ma'am.
What does it mean when you say compounding? I don't know what that means.
Okay, that's a good question. Compounding means figuring. So let's say that you put money in a bank, and when you put money in a bank, it earns interest. Well, depending on the situation, sometimes the account that you're using will add interest on only once every month. It will figure the interest based on how much money you have in your account. Oh, you have this much money in your account at this time, so we will give you this much interest on, let's say, you have $5,000 in your account. But then, after the next month, you have $6,000 in it. So now it will give you interest on $6,000. So, but if it's compounded continuously, that means every single millisecond, it's constantly figuring interest onto what you have. Okay? So when it's continuously, that just means it's always adding interest on for you. Okay? So P is the principal, A is the balance, A meaning like account balance, T is years, R is the interest rate. Notice it tells you that the interest rate has to be a decimal. So if it's 4%, you're not going to use a 4. You're going to use the decimal equivalent of 4%, which would be what? 0.04. I don't know if that's what you said. 0.04. 1.04 would mean 104%. So you're thinking the magic 1 that we've talked about over the years, but in this case, if it's 4%, you're going to use 0.04, okay? All right, and then N is the number of compounds per year. Okay, so we have a couple of examples. Get your calculators out. I really want to get through 2 examples before the hour is over, and we obviously are running out of time. So E, E is this natural base number called, the equivalent of it is 2.718. And a long time ago, mathematicians figured out this this value for E because as they were calculating this, this 1 plus 1 over x to the power of x, they realized that every single time they ever graphed this, it kept getting closer and closer and closer and closer to this E value, 2.718, blah, blah, blah. It's kind of like pi. It's an irrational number. It goes on and on and on and on and on. They realized that it kept getting closer and closer and closer to that, but it never got bigger than it. And so this right here has become a very famous number. And this formula, or this number right here, is part of the PERT formula that we just talked about a few minutes ago. A equals P times E to the RT formula, or RT power. The E is this number right here that mathematicians figured that when you are calculating interest rates, this number kept getting closer to 2.718, so they used it. They just came up with a letter to name it. They named it E, and that's what we use when we're compounding interest continuously. There's a couple of exercises here for you guys to figure out what is the value of E to the power of x when you replace the E with a -2. What happens when you replace the x with -2? So you're putting E to the -2 power. This one right here, you're putting E to the power of 0.4. Here you're putting E to the power of -0.5. So these three values right here, you need to calculate by using the E button on your calculator. And the E button is to the left of your 4. So you are going to press second ln meaning natural logarithm. So you do second ln, and then you type in -2. It's going to get you some answer. I don't know what it is. If I can have some help, that would be great.
1.353.
Okay. So we'll say 1.353.
It's 0.1.
0.1, excuse me. 0.1353. Okay. This one you're going to do second ln to the 0.4 power, and then the last one you do second ln to the -0.5 power. Okay, so I'm not even going to ask for decimal equivalents. You guys can do the button pressing on your own and get them in there. So this is the deal. I am going to give you your first homework assignment. Don't leave it till I give it to you. But these last two examples I was hoping to get you today. We're not going to. We'll talk about them tomorrow. So when you get to that part of your homework, you don't need to do it.